Hey guys, how's it going? This is Ross Critchlow. I have some of you guys in my class here from Sunrise Aviation. Some of you I work with, so good to see you guys again. This is my wind tunnel study. Alright, this slide discusses angle of attack and how it affects the lift and the coefficient of lift. So as we can see here in this area, we have our angle of attack in degrees, and we can see that some of those numbers are negative. And if you look at the lift number here, we have a negative lift number and a negative coefficient of lift when we have a negative angle of attack, which makes perfect sense because if we have a negative angle of attack, we're no longer producing a positive lift, and we're now decreasing our altitude. So you can see as the angle of attack decreases back to zero, we start producing a little bit more lift. It becomes a less negative number back to a positive one. Alright, so as we come to zero, a zero angle of attack, you can see that the number is still negative, which also makes sense because we have to have some form of angle of attack, some positive number to have a positive lift component or positive lift factor. So as you can see here, once we have our first positive number, the number 3, we start to have a positive reflection on our lift and our coefficient of lift. And as we go further down the line here to 21, that number, of course, increases drastically over the 0 because we've now multiplied our angle of attack by 7. So you can see here we have our max coefficient of lift and lift component. I would imagine that if we came into a stall, that this number would, of course, go back down to 0 or maybe a negative. I could be wrong on that, but that was just my hypothesis based off of what I see in the chart here. So if any of you guys know what that would do to our numbers here, just leave me a comment in the discussion post. All right, we'll move forward. And as you can see, Tom Cruise approves. All right, and here's that the chart that we've drawn out. Everybody should have pretty much the similar or same chart. So you can see that same reflection as our angle of attack increases from a negative over here at the 1. We have a increasing coefficient or lift production further down the line here towards the 13, which is the number 21 on our data chart. Alright, so this is the angle of attack and how it affects the drag. This is a pretty interesting one. As you can see, when we have a negative angle of attack, we're still producing a positive drag factor or coefficient of drag, which makes sense because we are exposing more of that aircraft surface to the relative wind. So you're never going to have a negative drag component here. It'll always be positive when we're flying. The only time I can imagine that it would be 0 is if we were maybe flying in a vacuum or space. I'm not sure much about space flight, haven't studied much on space flight, but I imagine that there is relatively no drag up there. I could be way off on that, so you guys can make a mockery of me if you want in the comments. But I would imagine that, like I said, if we were flying in space, that maybe we would have much less drag or 0 drag. But as we can see, as we come to 0 here, a 0 angle of attack, we're still producing, of course, a positive number, but it is much less than it is at a negative 15 degree angle here. All right, and then as we come to 0, that drag component or coefficient of drag reduces, and then as we, of course, increase our angle of attack again to the positive side, that coefficient of drag, of course, increases. All right, and the next slide will show the chart. All right, and here is our chart. So you can see even with the negative angle of attack, excuse me, which is here represented by the number 1, we still have a pretty high coefficient of drag. And as we decrease our angle of attack back to relatively 0, here noted by the 7, we're still going to have a positive drag factor. And then, of course, once we increase our angle of attack further, we start to add more drag. Alright guys, putting it all together here, Just kind of a review of the charts, the drag, and the lift, and how they act here in these pictures of the F-22s that I've selected for the slide. So as we can see by the F-22s here, they're both pictures are displaying high angles of attack for all four of these aircraft. But more specifically, this one here, we can see it's got a pretty steep angle of attack. So as it rolls into that angle of attack, of course, that lift is going to be spiked. If we were looking at it from a chart standpoint, our lift factor, our lift component, both of those numbers would spike. Our drag would also spike as we roll into a higher angle of attack. And these F-22s being capable of going full vertical, based on just my hypothesis and opinion, I would imagine that once the plane rolls into a full vertical, the angle of attack now is basically back to just a small degree, since the relative wind would be acting this way in a vertical ascent. That drag component would taper back off, and the lift would remain the same. And eventually, as they reach their ceiling, or as the weight factor gradually kicks in, that lift component would also slowly decrease back to 0 or a negative number if they got into a stall. I'm not sure what the ceiling is for an F-22, or if there even is one. I know some of these aircraft can fly kind of on the edge of space. So, but those are just my hypotheses. Like I said, previously, if I'm wrong, don't be afraid to correct me on it. Just kind of what I was thinking from looking at the charts and the capabilities of the F-22. So that's the end of my show here. Thanks for watching.